We've all seen the photos shared on social media. Rivers and lakes orange instead of blue. Moonscape landscapes, but here on Earth. They're understandably alarming. Acid rock drainage has been one of mining's worst historical legacies. That's why professionals in our industry have dedicated decades of research to both understanding it and preventing it. In 2009, the International Network for Acid Prevention published the first edition of the Global Acid Rock Drainage Guide. The GARD Guide deals with the prediction, prevention, and management of drainage produced from sulfide mineral oxidation, aka acid rock drainage, and the potential for metal leaching. So how does acid rock drainage actually occur? Well, let's start with something familiar. Fire. Fire needs three things: fuel, oxygen, and heat. Take away just one, and the fire stops. No oxygen, no fire. Acid rock drainage works in a similar way. It also has a triangle. It needs three things to occur: sulfide minerals, oxygen, and water. But here's another factor to consider. This reaction doesn't happen instantly. Unlike a flame, which you can see change in seconds, acid rock drainage is a chemical process that develops slowly over time, sometimes years, as these elements interact. The sulfides are bound to the metals we're trying to recover, like copper and nickel. That's how those metals exist in this. Metals like chalcopyrite and pentlandite. Our mining and processing facilities are designed to remove those sulfide-bearing minerals so they can be shipped out and turned into new products, not left behind to react. What remains on site matters though. That's why modern mining plans are always focused on breaking the triangle. Acid rock drainage only becomes possible if remaining sulfides are exposed to oxygen and water over time. And even then, it depends on whether other minerals are present that can naturally neutralize acidity. Proactive engineering design could mean keeping certain materials such as tailings underwater, cutting off oxygen, or keeping water away from rock through covered storage. Where necessary, projects are built with systems like liners, conveyance channels, and water treatment plants that are built in from the start to protect our water. For materials from the Duluth complex, decades of public and private research have demonstrated that the tailings that remain after processing contain less than 0.2% sulfides, a fraction of a percent, making them non-acid generating. That means the conditions needed for acid rock drainage are not only controlled, they're fundamentally limited by the material itself. Scientists and engineers designing today's projects don't just hope for the best. Our geochemists study the rock, our engineers design with intention, and our operators show up every day with a commitment to the environment we all share. Acid rock drainage is not inevitable. It's a process we understand and one we know how to prevent.